All right, so let's look at example 5. A sample of size 15 is drawn from a normally distributed population and has a sample mean of 35 and a sample standard deviation of 14. We want to construct a 95% confidence interval for the population mean and interpret its meaning. Now, very important, this is a small sample, smaller than 30. All right, so since the sample is smaller than 30, we really have to pay attention to what standard deviation we have. If we have the population standard deviation, we can use z of alpha over 2, just like we did in our examples from 7.1. But if we only have the sample standard deviation, we have to do the t distribution. So that's very important. So we're going to construct our 95% confidence interval, and this time, since we have only the sample standard deviation, we have to use the t distribution. Okay, so let's start by doing exactly the same thing we did before, and let me get this stuff from our prior examples off the page for us. All right, but remember before in 7.1, we first started out by taking our confidence level, changing it into a decimal and subtracting it from 1. That is still the case. And then we take that confidence level and divide it by 2, and we get 0.025 in this case. Now, our sample size was 15 in this instance. I believe I'm right in saying that. Oops, wrong one. Yes, sample size of 15. So we also have to calculate what's called degrees of freedom. And the degrees of freedom are always the sample size minus 1 in these particular samples. Okay, so when we're looking at these normally distributed populations, just the sample size minus 1. So our degrees of freedom are 14. Now, instead of using z of alpha over 2 in Excel, we're going to use a new command if we don't have the population standard deviation. We're going to use equal t dot inv. We're going to put in our probability of 0.025 and degrees of freedom of 14, and we get negative 2.145 if we round to 3 decimals. Okay, so let me go back. So t, oops, is negative 2.145, and of course we also have its opposite. Now once again though, our formula is x bar plus and minus t of alpha over 2 times our s divided by the square root of the sample size. So you might notice that that is really exactly the same procedure that we did before. The only difference is this t value is obtained in a different way. All right, so let's fill in. If we go back, our x bar and our standard deviation is, let's see, our mean was 35 and our sample standard deviation was 14. So 35 and 14, let's plug those in. All right, so we're going to have 35 plus and minus 2.145 times, is it 14 or 15? Losing track of it. 14. All right, so 14 over the square root of our sample size, 15. All right, now just as I did before with the prior confidence intervals, I'm going to do the right-hand side that comes after the plus minus in my calculator first. So I'm going to do 2.145 times 14 divided by the square root of 15. Now we get 35 plus and minus 7 point, and since our original data is to the whole number, I'm just going to go one decimal place, so 7.8. So we want to do 35 minus 7.8, oops, 7.8, and 35 plus 7.8. All right, so if we put 35 minus 7.8 into our calculator, we get 27.2. And if we put 35 plus into our calculator, we get 42.8. So our confidence interval in this example is 27.2 to 42.8. Now let's go back to the situation for a minute and let's do our interpretation. We can already say we are or I am, doesn't really matter. We are, this was 95% confident. The true, well, let's take a look back at our situation to see the true what. All right, so we were talking about a general situation. We really don't have a specific situation to apply it to here. So we'll just say the true mean. Go back here. The true mean is between 27.2 and 42.8. And there we have it.